Alright, so we're going to work with fundamental trig identities today, and you should have a handout or possibly a printout to recall the reciprocal identities. We've talked about these before. Quotient identities. New to us today are going to be our Pythagorean identities, and recall that we can also, if I was to solve this for sine squared of x, it would be 1 minus cosine squared of x is equivalent. So know that this can be rearranged to solve for different trig functions. So we'll want to know these, and these are very important, and this one's probably the most often used one out of the three. We also recall that the even odd identities, and the one that you want to remember is that cosine is the even function. Cosine and its reciprocal, it's even, because when we have the cosine of negative x here, we get just cosine of x on the right, which is why it's an even function. Now, we're basically I gave you a formula sheet that has your tools, and also here are some guidelines we're going to do. So before we get into verifying trig identities, let me just give you some potential things that you can try. Alright, so I'll give you a minute to write this down. Okay, specifically we're going to take identities, and when we're verifying them, we can use any of these techniques. And sometimes it's a matter of starting with one technique, trying to do it, being unsuccessful, and then starting over and trying another technique. So basically we work our way through this necessarily like a bag of tools until we find the one that works, or a particular method that works. And there's usually more than one way to go about it, but ultimately as long as you get the identity verified, that's what we're looking for, and that's how you'll be successful. Okay, so we start with our first. We want to verify each identity. So our goal is to prove that this left side does in fact equal this right hand side. And if we look back, we can rewrite the more complicated side as our first possible technique. And we usually try to do that often. We'll usually work with one side and just try to make it match the other. So a lot of times we will rewrite these in terms of sine and cosine. Let me see if it was over there anywhere. Okay, so first of all, let's just bring down sine of theta. Can I rewrite cotangent of theta in terms of sine and cosine? Yes, so what does it become? Cosine of theta divided by sine of theta. Good. Now what do you notice about that? Yes, they can cancel out. So even if it helps you to remember that this is just over 1, that's fine. But we can see that these are going to cancel, and that leaves us with cosine of theta equals cosine of theta. And therefore, done. Okay, next. So we're going to look, obviously the left is the more complicated side, so let's work with it. We want to try to simplify this in some kind of way using our formulas and identities to equal tangent of x. Okay, so when I think first of all sines and cosines, I could do something with this. This would give me like a fraction. This would give me a fraction, but this secant squared x, the only identity I have with secant squared x is going to be what? Right, our Pythagorean identities. So let's just kind of write that to the side. Well, we do have that one, but let's look. Let me go back to our thing so we can rewrite the more complicated side. We're working on that. Factor out a GCF is something. Did we even look for that yet? Let's see. Yeah, these have a GCF. Both of these terms have a cotangent in them, so let's do that first. Let's factor out a cotangent x. If I take cotangent x out of this first term, what's left? The secant squared x. Okay, and then I have minus. If I divide this by cotangent x or factor it out, I just have 1 as a placeholder. Okay, now look at your identities. We said we were still going to work with this at some point. Secant squared x, so that would give me this is equal to our tangent squared x. And I'll write that identity to the right so we can see how that happens. Alright, I think this is how this is presented on your formula sheet, but recall we can manipulate that so we can solve for specific trig functions. So when I'm looking for tangent squared theta, I subtract 1 from both sides. This is what we need. So secant squared theta is equal to tangent squared theta. And in our particular case, we were working with x. So now we have, let's drop down this cotangent of x. And we have cotangent of x times tangent of it, tangent squared x. Keep in mind where we're going. Now, can I rewrite cotangent in terms of tangent? Yes, so right, I can rewrite cotangent as 1 over tangent of x. Let me leave this. I bring tangent of x squared, and now what happens? Yes, 1 can cross cancel, so one of these cancels with one of these, and we're left with a tangent of x in the numerator, and that's what we were hoping for, so verified. So this particular case, our first step, we factored something out. So look for a factor, and then we used our Pythagorean identity, which we had to manipulate a bit, but that was what we used for this one. Okay, so our next one, we have a cosecant squared t over cotangent t, and I want it to be this side. Well, obviously writing things in terms of sine and cosine would just make this a fraction over a fraction, and then on top of it we have a squared, so that just seems like it would be more complicated. There's no GCF or anything. The next thing I'll look at and I'll notice is that this is one term. What's our right side? 2 particular terms, right? So eventually we're going to be making our way to 2 terms. The only thing we have to work with right now is this cosecant squared t. So let's look at our Pythagorean identities and see what we can replace. Cosecant squared t is going to be what? 1 plus cotangent, 1 plus cotangent squared t. I'll leave the denominator alone. And now, how could I possibly make this 2 terms now? Because I knew at some point I was going to make my way to 2 terms because the right hand side was 2 terms. Right? We can separate this into 2 fractions, so this will be the first one. So we'll just have 1 over cotangent t plus, and then what's this simplify to? Cotangent squared divided by cotangent is just 1 cotangent t. Alright, and always look back at your right. I see this part is where I want it to be, but what about 1 over cotangent t? Yeah, it's going to be one of our reciprocal identities, so this just becomes tangent t. I'll leave this one alone, and therefore it equals our right hand side, so verified. And this one we use a Pythagorean identity and then separate it into, let me go back and show you where we mentioned this one. Separate single term quotients into 2 terms. Okay, so that's one of our tools. Okay, here's the next one. I actually am just going to pause it for a minute and see if you can, how far you can get with this one on your own. Okay, the first thing we're going to do is separate this into 2. So it's going to be sine of theta over cosine of theta. And then I'm going to have 1 over cosine of theta. Sine of theta over cosine of theta just simplifies to tangent of theta. And then reciprocal identity, this is secant of theta. So this one was a rather simple one. So hopefully you were successful with this one. So secant of theta, it's verified. So